Okay, so this tutorial video is for your final test, your 10% vectors test, and we'll just kind of keep showing the thinking in terms of how I answered the question that's asked, does my answer make sense, kind of thing we're looking at in the other videos. In terms of what's coming up here, question A can be pretty much anything on vectors. It could nearly even be unseen, or else you can just try lots of questions from chapter 1. Questions B and C are usually, however, the work done by a force and the moment of a force. Okay. So if you go to page 222 of your manual, you'll see the last year's paper. If you want to see the questions, because I won't be writing them out fully again. Okay, so in this question we have three vectors A, B, C, and they're asking us to find two scalars, x, that shows numbers, x1 and x2, and a vector v. Okay, it asks us to find these things. So x1 is equal to, and this is just a scalar, the dot product of A and C. So A is 3 minus 1, 2, and C is 2, 2 minus 1. And the dot product is easy, you just multiply the numbers together and add them. So 3 by 2 is 6, plus minus 1 by minus 2 is minus 2, plus 2 by minus 1 is minus 2, 6 minus 2 minus 2 is equal to 2. Done. x2 is A dot B. A is still 3 minus 1, 2, and B is, now there's no I there, so that means it's 0 along the x direction, 0i. And then 1j, 1k. So we end up with 3 by 0 is 0, plus minus 1 by 1 is minus 1, plus 2 by 1 is 2. So 2 minus 1 is equal to 1. And then V is equal to B cross C. Okay, so B cross C, cross product. So you got your dot product, which is easy, which also is called scalar product. And then the cross product is your vector product. The answer is a vector. So dot product is answer is a scalar, is a number, check. This answer is a vector. And this is the thing where you find the determinant of I, j, k, and then the components of B, which are 0, 1, 1, and the components of C, which are 2, 2, minus 1. And how you calculate these, as when you did the matrices, you write the first two columns again, I, 0, 2, J, 1, 2, and you do right down diagonal minus left down diagonal. So let's say right down diagonal minus left down diagonal. And you're multiplying along these. So yeah, the reds, the right down diagonal. So I by 1 by minus 1. Now make sure and make this bit neat, because it's quite easy to lose these little signs, these minuses, etc. So just be careful there. So I by 1 by minus 1 is minus I. J by 1 by 2 is 2j. K by 0, it's going to be 0, so I can actually leave it out. Takeaway. The left hand diagonal is J by 0, it's 0, forget about it. I by 1 by 2 is 2i. K by 1 by 2 is 2k. And being careful about this, we have minus I minus 2i, that's minus 3i. 2j, there's no j's over there, so that's 2j. And then there's no k's here, minus 2k. Okay, so this is the vector v. And the question is, hence investigate whether or not A, vector product with v, is equal to x1 times b minus x2 times c. Now if I'm asking you to show or investigate if two things are equal, calculate them separately and then see what's going on at the end. So the first thing we might do, we probably just about have space to do the vector product of A and V. So A cross A cross V. I, j, k. The components of A are 3 minus 1, 2. And the components of V, this is V here, V equals equals equals, minus 3, 2, minus 2. Minus 3, 2, minus 2. As before, we do first two columns again. I, 3, minus 3. J, minus 1, 2. And we do the right hand diagonals minus left hand diagonals. So that by that by that, that by that by that, that by that by that. That's the right hand diagonals. Take away left hand diagonals. J by 3 by minus 2, I by 2 by 2, K by minus 1 by minus 3. So you get equals. So the red write downs, I by minus 1 is minus I by minus 2 is plus 2I. Next one, J by 2 by minus 3 is minus 6J. K by 3 by 2 is plus 6K. Take away the next one, the left hand diagonals. So J by 3 by minus 2 is minus 6J. I by 2 by 2 is 4I. And then K by minus 1 by minus 3 plus 3K. And so we get 2I minus 4I is minus 2I. Minus 6J minus 6J is minus 6J plus 6J, which is 0. You want to be very careful with the signs here. There's none of those. No J's. 6K minus 3K is then plus 3K. Okay, so that's the left-hand side. That's A cross V. Now let's look at x1 times B minus x2 times C. And see, do we get the same thing? So x1 times B minus x2 times C. So x1 is just 2, B is this yoke, minus x2 is 1, and C is this yoke. Of course, I don't have to get them here, they're on the question. So this is 2, 2 minus 1. And then multiply this in. So a scalar multiplication, you multiply all of them. So you're going to have 2 by 0 is 0, 2 by 1 is 2, 2 by 1 is 2. Take away 1 by 2 is 2. Oh, I have to be careful here. I'm just going to multiply into 1. So it'll be 1 by 2 is 2, 1 by 2 is 2, 1 by minus 1 is minus 1. And now let's go. 0 minus 2 is minus 2. 2 minus 2 is 0. And 2 minus minus 1 is 2 plus 1, which is 3. Minus 2 along the x, 0 along the y, 3 along the z. Same as minus 2 along the x, 0 along the y, 3 along the z. So this is indeed equal to A cross V. So the investigation was investigate whether or not, well, we found that they were equal. Okay. Does the answer make sense? Okay, in terms of things making sense, x1 is said to be a scalar. It has to be a number. It is. V, it's a vector. So here, like, I have the arrow on it. That's in the question as well. It's certainly a vector, and we end up with a vector. These two objects are both vectors. If you got a number here and a vector here, something's gone badly wrong, although I could ask you, you know, investigate whether this and the magnitude of these are equal, which they certainly wouldn't be, because the magnitude of this is a scalar or a number and this thing is a vector. They couldn't be equal. But that's that question done at any rate. Okay, so anything can kind of pop up there, but after that you're looking most likely at a work question and a moment question. Okay, as they go, this one isn't too bad. Okay, under gravity, a force vector for gravity, which is familiar enough if you look at it. An object of mass of 100 kg located at a point A slides straight down a smooth plane until it is located somewhere else. Assume that the distances are measured in meters, and there's also a mention of newtons. Find the work done by the force of gravity. So the plane is something like this, and it goes at some point on the plane here A, and it falls down to B, So that's the displacement through which the object falls. So there's just two formulas here. You need to know that work is a scalar. It's going to be the scalar product. And then the other one is the moment is a vector, is the vector product. And both of them are d by f, but you got to know. So that order is actually not important for work, but it's very important for moment. Let's see what we got. Let's write down work is d by f, and work is a scalar, so it's a scalar product. The force vector is given. We just have to find the displacement from A to B, which is nothing other than point B minus point A. The coordinates of B are in the question, -2, -3, -1. Take away A, which is 1, 1, 2. So we get -2 -1, which is -3, -3 -1, which is -4, and -1 -2, which is -3. So that's the displacement vector. So we can find the work now. Displacement dotted with force. Displacement is -3, -4, -3, and the force is very easy. It's 0I, 0J, -980. And then -3 by 0 is 0, plus -4 by 0 is 0, plus 3 by -3 by 980, which I really should be able to find. I think it's 2,960. Yeah, that sounds good. I calculator otherwise. And then you just need to get the units right. So it's going to be units of distance by or units of displacement by units of force. Displacement is meters and the force is newtons. So if you want, you can just write meter newtons. Might be more natural for you to write Newton meters, and I'll accept this. You can convert. You can say that that's a joule if you want, because they're both SI units. That's that. And then finally part C, moment question. Now if there's a picture here, I recommend that you use it, because the big issue here is the displacement. So like before I even start, let me write down something. The moment is going to be the displacement crossed with the force, vector product with the force. The displacement is the displacement of the force from the pivot. So it's the vector that goes from the pivot to the point where the force acts. In this one, in this particular question, there's a picture of a door. The hinge is the pivot and the door handle is where the force acts. So it's going to go from the hinge to the thing. You might be given an abstract one where you have to draw it yourself. Let's kind of do that here, say. So suppose you're asked to find the moment about this point A due to a force F acting at B. You need to know that the displacement goes from the pivot to the point where the force acts. In this question, A to B, which is B minus A, B where the force acts is where the doorknob is, which is given as 0.6, 0.61. Take away A, which is that should be the hinge, which is 0.01. And this looks like 0.6 minus 0 is 0.6, 0.6 minus 0 is 0.6, and 1 minus 1 is 0. Okay. As I said, I would draw this on the page, sorry, on the diagram. Obviously you can't do that, can you? So I would just take a little sketch, because what will cost you marks are there's two ways that you can end up in big trouble. The first is that you get this order wrong. The order of a cross product / order of a vector product is important. And the second thing is I need to see that displacement going from the pivot to the point where the force acts. The other way around. This question's worth 9 marks. You're actually only getting 5 if you mess up all of those. Okay. Right, I think we're ready to go because the force is there. So the moment is the displacement cross with the force in the question. How do you find the cross product? You do I, J, K. Displacement is 0.6, 0.61. It's probably a bit small here. I probably should have done it a bit bigger. You see, I might get confused here. The force then is -1 along the x, 2 along the y, 1 along the z. And as before, how do you calculate these? You write the first two columns again. I 0.6 minus 1, j 0.62. And we do our right down diagonal minus left down diagonal. That by that by that, that by that by that, that by that by that. And obviously if you do this with a vector product and this with a scalar product, you're doing very poorly. So don't mess them up. That will really cost you. And you shouldn't really, because you need to know, as long as you know that this scalar product gives you a number, you should be okay, because you need to know that work is just a scalar, but moment has a direction. And the direction really is just capturing, is it up or down? And the other one. See here, because I draw it a bit funny, could have drawn it a bit bigger and might have been a bit easier to follow. Anyway, so the right down diagonals, I see I by 0.6 by 1, which is 0.6i. I see j by 1 by minus 1, that's minus j. I see k by 0.6 by 2, that's plus 1.2k. Takeaway. Left down diagonals, j by 0.6 by 1 is 0.6j. I by 1 by 2 is 2i. K by 0.6 by minus 1 minus 0.6k. Right, looks pretty good. So I got 0.6i minus 2i, that's minus 1.4i. I see minus j minus 0.6j, that's minus 1j minus another 0.6j is minus 1.6j. And then finally 1.2k minus minus means plus, 1.2k plus 0.6k is 1.8k. Now we're doing very well to there. We can kind of mess it up a bit yet. So there's two things that we have to, three things we want to do here. Have I answered the question that's asked is the first thing. Did I find the moment of the force? Yes. What might happen here is I'll ask you for the magnitude of the moment, in which case you're very, very close. All you have to do is just go off and find the magnitude of this using Pythagoras. Does the answer make sense? Well, all you can say really is that, well, the answer is a vector, that's good. The one thing we're missing out on here, if you're an engineer, you want to use units. And the units, it says meters, it says newtons, so it's Newton meters. I recommend putting brackets around that. You shouldn't really call this a joule. It's a joule per radian. But yeah, that's your tutorial for the vectors.